Detection of adulteration in milk. Adulteration in milk considerably reduces the quality of milk. Soap, acid, starch, table sugar, and chemicals like formalin are some of the adulterants added to milk. Most of the chemicals used as adulterants are poisonous and can cause health hazards. Here are some tests to find out some of the common adulterants in milk. Materials required: milk, methylene blue, test tubes, water bath, concentrated HCl, risosinol, iodine solution, concentrated sulfuric acid, 0.5% ferric chloride solution, phenolphthalein indicator, hot water, 2% sodium hydroxide, 2% sodium hypochlorite, 5% phenol. Procedure: arrange the required materials on the lab table. Detection of table sugar in milk. Pour 10 ml of milk into the test tube labeled table sugar and using a pipette add concentrated HCl into the tube. That should be done in the fume hood. Now shake the test tube gently so that the milk gets precipitated. Weigh 100 mg of risosinol, add this to the precipitated milk, then shake the test tube well. The color of the milk solution changes to light brown. Now place the test tube with the test tube holder in a water bath at 100 degrees Celsius for 5 minutes. The color of the milk solution turns red, which shows the presence of table sugar in milk. If the color remains the same, it denotes the absence of table sugar in milk. Detection of starch. Pour 3 ml milk in a test tube labeled starch. Now place the test tube with the test tube holder in a water bath at 100 degrees Celsius. After 5 minutes, remove the tube from the water bath and allow it to cool. Using a dropper, add 2 to 3 drops of iodine solution to the test tube and shake it well. If the color of the milk solution turns yellow, it indicates the absence of starch. Dark blue color indicates the presence of starch in milk. Detection of benzoic acid and salicylic acid. Pour 5 ml milk from the beaker into the test tube labeled acid. Add few drops of concentrated sulfuric acid into the milk and shake the test tube gently. This should be done in the fume hood. You will observe that the milk is getting precipitated. Now using a dropper, add 0.5% ferric chloride solution drop by drop and mix it well. A buff color indicates the presence of benzoic acid. If you observe a violet color, it shows the presence of salicylic acid in the milk. Detection of soap. Pour 10 ml milk into a test tube labeled soap, then add 10 ml hot water to the milk. Add 1 to 2 drops of phenolphthalein indicator into the test tube and mix this gently. If the color turns pink, it indicates the presence of soap in the milk. If the color remains the same, it shows the absence of soap in milk. Detection of formalin in milk. Pour 2 ml milk into a test tube labeled formalin. To this, add 2 ml of 90% sulfuric acid containing ferric chloride using a glass pipette. This step should be done in the fume hood. A purple-violet ring formed at a junction indicates the presence of formalin in the milk. Detection of ammonium sulfate in milk. Pour 1 ml milk into a test tube labeled ammonium sulfate. Pipette out 500 microliter of 2% NaOH solution and add this to the test tube. Discard the used tip and insert a new tip. Pipette out 500 microliter of 2% sodium hypochlorite and add this to the milk solution. You will notice that the color has turned light yellow. Insert a fresh tip and add 500 microliter phenol solution and mix this well. The milk solution turns light bluish color. Keep this test tube in a water bath at 100 degrees Celsius for 20 seconds. After 20 seconds, the color turns deep blue, indicates the presence of ammonium sulfate. If the solution turns pink, it indicates the absence of ammonium sulfate. Detection of microorganisms in milk. Pour 10 ml milk from the beaker into the test tube labeled microorganism. Add 8 to 10 drops of methylene blue into the test tube containing milk and mix the contents well. The color of the milk solution turns blue. Close the test tube using cotton ball, and keep it in the incubator for 30 minutes at 37 degrees Celsius. If the blue colored milk solution turns white immediately, it indicates a large count of microorganisms in the milk. If the color remains the same, it indicates the presence of fewer numbers of microorganisms in the sample.